In the vast silence of space, 13.6 billion years ago, a singular event took place. The universe was born from a point smaller than a speck of dust, in what we now call the Big Bang. This cataclysmic burst of energy didn't just create space and time, it ignited a chain of events that led to the formation of galaxies, stars, and the intricate web of life itself. But the birth of the Milky Way, our galaxy, was a story told in the language of time and forces beyond our comprehension. In those early moments, the universe was an incredibly hot and dense soup of particles, racing in all directions. But as it cooled, gravity began to take hold. Slowly, the first atoms began to form, mostly hydrogen, the simplest and most abundant element. These atoms were scattered throughout the vastness of space, but where gravity had its way, the gas started to clump together. Tiny pockets of matter gathered, coalescing into larger structures. Over time, these clumps became the building blocks for galaxies. What we now call the Milky Way was born out of one such gathering, a swirling mass of gas and dust, eventually spinning into the shape we recognize today. But what may seem like an inevitable unfolding of events was, in reality, influenced by something far more elusive. Dark matter, an invisible force, began to shape the galaxy. While we can't see it, we know it's there, interacting with the matter we can observe through its gravitational pull. This unseen force played a key role in forming the early structure of the Milky Way, guiding the formation of clusters and helping the galaxy take its familiar spiral shape. In those first few 100 million years, gravity continued to shape our galaxy's framework. But something even more mysterious was at play. There was another hidden force, dark energy, that began pushing things apart, accelerating the expansion of the universe itself. This strange force would go on to affect not only the Milky Way, but the entire universe, making it grow at a pace we could never have imagined. But what if the universe itself has hidden forces shaping our galaxy in ways we never expected? Forces we can't fully comprehend, yet can feel their effects everywhere, from the way stars swirl in the night sky to the very expansion of the cosmos itself. What if these forces aren't just shaping the galaxies, but also the very course of existence? It's easy to imagine the Milky Way as simply another galaxy in an infinite universe. Yet its origin is far more intricate, woven together by cosmic forces that stretch the limits of our understanding. As we venture deeper into the secrets of the Milky Way, we must ask ourselves, what did we miss in the beginning? What else could have shaped this galaxy in ways we are only just beginning to understand? And so, from the birth of the Milky Way, we find ourselves standing on the edge of something much greater, a galaxy in motion, its stars, dust, and energy, bound together by forces unseen, guiding its evolution and making it the awe-inspiring spiral we gaze upon from Earth. As we move forward, we will explore the very forces that continue to sculpt this magnificent galaxy, laying the foundation for the stars that will illuminate its vast expanse. We look up at the stars and see their light flicker across the night sky, imagining that we understand the universe as it stretches infinitely before us. But what if we've only scratched the surface of reality, unable to see 95% of what truly exists? This is the secret lurking just beyond our senses: dark matter and dark energy, invisible forces that shape the Milky Way and the universe as a whole, yet remain shrouded in mystery. The Milky Way, like every galaxy, is not just a collection of stars and gas. It is held together by invisible forces, forces that we know exist because we can see their effects, even if we cannot see the forces themselves. These forces are dark matter and dark energy, two concepts that scientists are only beginning to understand. Dark matter is the hidden mass that makes up about 85% of the matter in the universe. Despite its vast influence on the motion of galaxies, we cannot see dark matter directly. It doesn't emit light, nor does it absorb or reflect it. But its presence can be inferred by the way it affects the gravitational pull of galaxies. Without dark matter, the stars in the Milky Way would fly apart, unable to hold themselves together. It's the invisible glue that binds everything in the galaxy, a force that keeps the stars spinning in their orbits, even though we can't touch or see it. Then there's dark energy, a force so strange that it challenges our very understanding of physics. While dark matter holds galaxies together, dark energy works in the opposite direction, pushing the universe apart at an accelerating rate. This unseen force is responsible for the expanding universe, stretching the fabric of space itself. But its true nature remains a puzzle, an enigma that scientists are scrambling to understand. It's as though the Milky Way, like all galaxies, is being subtly pushed apart by an invisible hand. Imagine for a moment, what if 95% of the galaxy is completely invisible to us? What if we've been observing the stars for centuries, thinking we understand the universe, but all along, the most important components, the forces that control the destiny of galaxies, remain hidden from our view? These forces are the foundation upon which the Milky Way is built. They influence the galaxy's structure, determining everything from the shape of its spiral arms to the distribution of stars across its vast expanse. But dark matter and dark energy are not just shaping the galaxy. They may hold the key to understanding the fate of the entire universe. If we can learn to understand them, we might uncover the ultimate secrets of existence itself. As we probe deeper into the mysteries of the Milky Way, we begin to see how dark matter and dark energy are far more than cosmic curiosities. They are the fundamental forces that govern the very structure of the galaxy. But these invisible forces also push us into deeper, more speculative territory. What if dark matter is not just a force, but a clue, a key to understanding the unseen dimensions of reality? What if dark energy is something even more strange, an aspect of the universe that has yet to be fully discovered, a force that could change everything we know about space, time, and existence? This intrigue leads us naturally into the next chapter, where we begin to examine the creation of stars and the complex radiant regions of the Milky Way, where these dark forces shape the cosmos. As the galaxy takes form, these invisible powers become even more essential to understanding how stars are born and how they sustain the galaxy's ongoing dance of light and gravity. The Milky Way, vast and beautiful, is home to countless stars, each one with its own story, its own beginning. But few tales are as mysterious as the birth of stars. Imagine the Milky Way as a giant cosmic furnace, where gas and dust collide and transform into brilliant balls of fire. This is where the magic happens, the very process that has shaped the galaxy for billions of years. In the heart of the Milky Way's spiral arms, vast clouds of gas and dust drift in space, and within these clouds lie the seeds of stars. These regions, known as nebulae, are cosmic nurseries, the places where new stars are born. These colorful, glowing clouds of gas may appear calm and serene from afar, but inside them, there is chaos. The gas and dust are constantly in motion, swirling under the influence of gravity. As the matter clumps together, the pressure increases and the temperature rises. Eventually, this heat and pressure will ignite nuclear fusion, and a star is born. But how do these clouds of gas and dust transform into something as powerful and radiant as a star? The process begins with a single faint disturbance, a shockwave from a nearby star exploding, a passing cosmic event, or even the collision of nearby molecular clouds. This disturbance triggers the collapse of a gas cloud under the force of gravity. As the gas contracts, it heats up, and over millions of years, a dense core forms at the center, a protostar. It is here, in the heart of these nebulae, that the birth of a star begins in earnest. What if these vibrant nebulae are not just clouds of gas and dust, but cosmic wombs where stars are born? Yet we still don't fully understand the process. Despite centuries of study, the full mechanics of stellar birth remain one of the great mysteries of the universe. We know that once the temperature and pressure become high enough, nuclear fusion begins the process that powers stars for billions of years. But how exactly does the universe manage to make this happen, time and time again, across the vast reaches of space? The Orion Nebula, one of the most famous and beautiful nebulae, is a perfect example of this stellar birth. It's a region where thousands of new stars are forming right now, hidden from view by the thick clouds of gas. Yet, if we could somehow peer into the heart of it, we would see the delicate and chaotic dance of gas and dust slowly coming together to form something entirely new, something that will shine brightly for millions, even billions, of years. These nebulae are more than just beautiful objects in the sky. They are the very birthplace of the stars that make up the Milky Way. The spiral arms of the galaxy are alive with these stellar nurseries, each one contributing to the galaxy's vibrant energy. As the stars are born, they begin to move, to shine, and to influence their surroundings. Their light radiates outward, shaping the galaxy around them, creating a dynamic, ever-changing environment. And yet, despite the beauty and power of this process, we are left with more questions than answers. What drives the creation of a star? What triggers the collapse of a gas cloud into a protostar? Could there be more secrets hidden within the nebulae? Secrets we have yet to discover? As we explore the Milky Way's structure further, we will begin to uncover these hidden processes. What makes the galaxy a living, breathing entity, constantly evolving, constantly changing? The birth of stars is the foundation of the galaxy's existence, and in understanding this process, we gain a deeper understanding of the universe itself. But the mysteries of star formation are far from over. They are a gateway to further exploration, leading us into the hidden regions of the Milky Way, where forces we can't see shape the very future of the stars we rely on for light and life. The journey has just begun. The Milky Way, stretching across the cosmos in a beautiful spiral, is a galaxy unlike any other. From the Earth, we can only catch fleeting glimpses of its vastness, but even these fleeting views are enough to remind us of the immense mystery it holds. It's easy to imagine that the galaxy is fully mapped, its structure revealed to us in all its glory. But what if there are regions hidden, elusive, that remain just out of reach, even for the most advanced telescopes? Over the years, astronomers have worked tirelessly to chart the Milky Way, employing methods that have transformed our understanding of this cosmic masterpiece. Yet, despite their tireless efforts, large swaths of the galaxy remain beyond our grasp. The Milky Way is a sprawling, complex system, and studying it is like trying to trace a sprawling spider's web across the sky. The difficulty lies in its depth. Its vastness extends far beyond what we can see with the naked eye, or even with some of the most advanced instruments known to man. To map the galaxy, astronomers rely on tools that allow us to peer beyond the visible spectrum, beyond the stars that twinkle in our night sky. Radio telescopes, for example, can detect signals from deep within the galaxy, offering a glimpse into regions shrouded in dust and gas. These signals provide information about the structure of the Milky Way, revealing the positions of stars, star clusters, and nebulae. But even with these advanced methods, much of the galaxy remains hidden, as though it is deliberately keeping its secrets from us. Infrared observations further enhance our understanding. Unlike visible light, infrared radiation can penetrate the thick clouds of dust that obstruct our view. This technology reveals the heat emitted by stars, stellar remnants, and the faint glow of regions still in the process of forming. Through this lens, we begin to see the galaxy's true form, its spiral arms, its galactic plane, and its dense center. But the full picture remains incomplete. As we gather more data, the pieces slowly fall into place. But even today, much of the galaxy's vast reaches are still a mystery. Could there be entire regions of our galaxy that remain hidden, even to the most advanced telescopes? The answer is not as simple as a yes or no. The Milky Way is constantly evolving, with new stars being born and dying in rapid succession. Its shape is not static. Some regions are more easily observed than others, while some may be obscured by dense interstellar dust. And yet, each new discovery seems to unlock a little more of the galaxy's secrets, revealing that there is always more to uncover. As we peer deeper into the heart of the Milky Way, the structure of the galaxy itself comes into sharper focus. The next step is to examine its most intriguing feature, its spiral arms, which hold many of the galaxy's stars, nebulae, and countless mysteries waiting to be uncovered. At the very center of the Milky Way lies a region where the very fabric of space and time seems to twist and contort, a place of unimaginable density, where the laws of physics are pushed to their very limits. This is the galactic core, a region that has fascinated astronomers and scientists for centuries. Within its heart, we find one of the most mysterious and powerful objects in the universe, a supermassive black hole known as Sagittarius A*. Sagittarius A*, though invisible to the naked eye, is the gravitational anchor around which the entire galaxy revolves. It holds a mass equal to that of 4 million suns, packed into an area so small that even light cannot escape its grasp. The black hole's influence extends far beyond its immediate vicinity, bending light and warping space-time in ways that challenge everything we thought we knew about gravity. It's as though the center of the galaxy holds the key to understanding the deepest mysteries of the universe. What secrets lie within the heart of our galaxy, where time and space seem to bend? The gravitational forces at play here are so immense that they distort the very structure of the galaxy. The stars closest to Sagittarius A times are moving at incredible speeds, their orbits affected by the intense gravity of the black hole. But even more remarkable are the strange phenomena that occur in the galactic core. High-energy events, such as bursts of radiation and the occasional flare of light, erupt from the region around the black hole. These bursts, though brief, are some of the most energetic events in the universe. The galactic core is not just a place of black holes and radiation. It is also home to dense star clusters, ancient remnants of stellar populations that have lived and died in the harsh environment. The stars in this region are old and enigmatic, their movements often unpredictable due to the immense gravitational forces at work. These stars, locked in their orbits around Sagittarius A*, are the survivors of a tumultuous history, ones that have withstood the intense pressure of the galactic center for billions of years. But despite all that we know, much about the galactic core remains shrouded in mystery. We are only beginning to understand the true scale of the phenomena that occur here. What are the objects that we have yet to discover within the core, hidden behind the veil of radiation and darkness? Could there be even more dangerous or enigmatic entities lurking in the shadows, waiting to be uncovered? As we continue to study the galactic core, we uncover more clues about the nature of the universe itself. The heart of the Milky Way holds secrets not just about our galaxy, but about the very forces that govern the cosmos. It is a place where the boundaries of science are stretched to their limits, where the rules we know may not apply in the way we expect. And yet, the mysteries of the core are just the beginning. For what lies beyond within the spiral arms of the galaxy is just as intriguing, if not more so. The Milky Way is often described as a vast, swirling disk, its shape defined by graceful spiral arms that stretch out like fingers of light. These arms are not just aesthetic features, they are the galactic highways, filled with the stars, nebulae, and cosmic phenomena that define the galaxy. The spiral structure is a key characteristic of many galaxies, and it is here, in these luminous arms, that much of the galaxy's most remarkable and mysterious events take place. The formation of these arms is driven by a phenomenon known as spiral density waves. These waves, caused by gravitational interactions between stars and gas clouds, create a ripple effect through the galaxy. As the waves pass, they compress gas and dust, triggering the birth of new stars. These regions of active star formation give the arms their luminous glow as young stars light up the gas and dust around them. The spiral arms of the Milky Way are teeming with life-new stars, new planetary systems, and new mysteries waiting to be uncovered. But what lies hidden within these arms? Could there be ancient civilizations, long forgotten by time, hidden among the stars? Or are there objects so strange, so elusive, that we have yet to even detect them? The possibility of rogue planets, planets that wander freely through space, not bound to any star lurking within the spiral arms, is one such mystery. These planets, if they exist, would be invisible to most telescopes, drifting in the vast emptiness of space. They would hold secrets of their own, potentially hiding clues to the origins of life, or even harboring life themselves. As we peer deeper into the spiral arms, we also encounter the strange and elusive dark matter that is thought to permeate these regions. Dark matter, which makes up the majority of the galaxy's mass, is invisible to our current instruments. But its presence is felt in the way it affects the motion of stars and gas clouds. What if some of the dark matter in the spiral arms is concentrated in regions we cannot yet detect, further altering the galaxy's structure in ways we don't fully understand? And what of the objects that have yet to be discovered within these arms? Could there be other phenomena, perhaps even alien technology, or remnants of ancient civilizations hidden in the vastness of space? The idea of discovering something far beyond our current understanding of the galaxy is tantalizing. Perhaps the spiral arms, with their stars and nebulae, are more than just beautiful regions of space. They may hold the key to understanding the deepest mysteries of the Milky Way. What if there are still cosmic objects waiting to be discovered? Objects that could change everything we think we know about the universe. The spiral arms of the Milky Way, vast and uncharted, are full of hidden potential. As we explore these regions, we uncover the past, present, and future of the galaxy, one secret at a time. But even as we make new discoveries, the question remains: what else is hidden, waiting for us to find? The wonders of the spiral arms are not just a glimpse into the past. They are the very heartbeat of the galaxy, constantly shaping and reshaping the Milky Way. The stars born here fuel the galaxy's growth, and the phenomena we encounter in these arms will guide us into the future of our exploration of the cosmos. With each new discovery, we edge closer to understanding the true nature of the Milky Way, but the journey has only just begun. The universe is a vast and uncharted expanse, and within it lies an endless question that has haunted humanity for centuries. Are we alone? The search for life beyond Earth, once a speculative dream, is now grounded in the exciting field of exoplanet discovery. Over the past few decades, astronomers have turned their gaze to the stars with unprecedented precision, seeking planets that might harbor life in distant corners of the Milky Way. These planets, located in what is called the habitable zone, are critical in our quest to answer one of the most profound questions of all time. The habitable zone is often described as the region around a star where conditions are just right for liquid water to exist, neither too hot nor too cold. Water, as we know, is essential for life as we understand it. So this zone becomes the primary target for the search for life elsewhere in the galaxy. But how do we find these planets, light years away, hidden among the stars? One of the most significant tools in this search has been the Kepler Space Telescope, launched by NASA in 2009. Kepler's primary mission was to identify Earth-like planets orbiting other stars, using a method called the transit technique. When a planet passes in front of its host star, it causes a slight dimming of the star's light. By measuring this dimming, scientists can infer the presence of a planet and, through further analysis, determine whether it resides within the habitable zone of its star. In its 9 years of operation, Kepler discovered thousands of exoplanets, many of which lie in their star's habitable zone. Among these, there have been several candidates that have ignited the imagination of scientists and dreamers alike. Planets such as Kepler 452b, often referred to as Earth's cousin, orbit a star very similar to our own Sun and sits in the habitable zone. It could, in theory, host liquid water on its surface. But despite the promising data, the question remains: what lies on these planets? Could they be home to life, perhaps in forms so different from our own that we would not recognize them? Could we be on the verge of discovering the first signs of life beyond Earth, hidden in the Milky Way? As technology continues to advance, so too does our ability to study these distant worlds. With future missions, such as the James Webb Space Telescope, scientists are poised to look even deeper, searching for the faintest signs of atmospheres that could support life, and possibly even biosignatures, the chemical fingerprints of life itself. Yet, even with all this progress, the true nature of these planets remains elusive. The question still lingers: what makes a planet truly habitable? What conditions are necessary not just for water, but for the complex interactions that could lead to life as we know it? And, perhaps the greatest mystery of all, are we truly alone? Or is there, in some distant corner of the Milky Way, another civilization staring up at the stars, just as we do? As we continue our search for these distant worlds, it is clear that the path is not straightforward. The challenges of detecting life, or its potential signs, are immense. But the possibility remains tantalizing, and with every new discovery, we come closer to unlocking the great secret that has always existed just beyond the stars. As we look to the stars, searching for planets that could harbor life, another mystery beckons: the strange and unexplained signals that occasionally ripple across the cosmos. These enigmatic signals, often detected by radio telescopes, have raised more questions than answers. What are they? Could they be a sign of extraterrestrial intelligence reaching out across the vast expanse of space? Or is there a more natural explanation, one that we simply don't yet understand? Fast radio bursts, FRBs, are one of the most perplexing of these cosmic phenomena. Discovered only a few decades ago, FRBs are brief, intense bursts of radio waves that seem to originate from distant galaxies. These signals last only a few milliseconds, but contain enormous amounts of energy. Their origin is still a mystery, and scientists have proposed a number of theories. Some suggest that they could be the result of collapsing stars, while others speculate that they may be the product of advanced technology from civilizations far beyond our own. What if these mysterious signals from deep space are evidence of alien intelligence? What if, instead of a natural cosmic event, these bursts are the result of something far more deliberate, an attempt to communicate from another star system, a message lost in the vastness of space for millions of years? In addition to FRBs, astronomers have detected other strange phenomena that defy easy explanation. Unusual light patterns, the kind that don't quite match the behavior of natural stars, have been observed in distant regions of space. These could be the result of unknown astrophysical processes, but they also spark the imagination. Could they be signs of technological activity, something far beyond our current understanding of physics? The search for answers to these phenomena is not just a scientific endeavor. It taps into something deeply human, a yearning for connection. The thought that there could be messages waiting to be decoded from distant stars is as captivating as it is mysterious. The very nature of these signals suggests that there may be more to the universe than we've ever imagined, and the possibility that we're not alone is ever more tantalizing. Are these mysterious signals from deep space evidence of alien intelligence, or are they something else entirely? Perhaps the signals are just the first clue, the first whisper from the vast unknown that beckons us to look deeper. And as we continue to refine our technology and listening capabilities, we may begin to unlock the true nature of these signals and what they could mean for our place in the galaxy. As we explore the possibility of extraterrestrial life, we are faced with the reality that we may be looking in the wrong places. What if the life we are searching for is not the simple organisms we imagine, but something far more complex, hidden in a way that we cannot yet comprehend? The signals we are hearing may not just be distant echoes, they could be a signpost pointing us toward the next great mystery in the search for life. The discovery of these signals could be the key to understanding not only the cosmos, but also our place within it. As we move forward, the next step is to consider the possibility of civilizations hidden in the Milky Way. Civilizations that have remained hidden from our view for millennia, perhaps even older than we can imagine. The search for life in the Milky Way is often framed as the search for planets where conditions are right for life. But what if the discovery of life is not simply about finding planets where life could exist, but instead uncovering the remnants of ancient civilizations that once thrived across the galaxy? What if, buried within the vast stretches of space, there are lost civilizations, advanced beings, whose technology and culture vanished long before we even began to understand the stars. The Fermi paradox, the apparent contradiction between the high probability of extraterrestrial civilizations and the lack of evidence for them, has long been a subject of intrigue. If there are so many potentially habitable planets in the Milky Way, why haven't we encountered any signs of intelligent life? One possibility is that advanced civilizations may have risen and fallen long before humanity even appeared on the scene. Perhaps these civilizations lived and thrived in the distant past, their traces hidden from our view by time, distance, or the very nature of the galaxy itself. Some theories suggest that these ancient civilizations could be hidden within the vast, dark regions of the Milky Way, far from our current observation zones. Perhaps they exist on planets deep within the galaxy's spiral arms, or in the shadowy regions of the galactic core, where the light from nearby stars is blocked by thick clouds of dust. These civilizations could have left behind signals, remnants of their technology, or even structures that we haven't yet discovered. What if ancient civilizations once thrived in the Milky Way, and we're only now beginning to uncover their remnants? The very idea of lost civilizations, thriving for eons before disappearing into the void, is a concept that fuels both scientific and speculative curiosity. Could their technology be so advanced that we, with all our current capabilities, would be unable to recognize it? Or, perhaps, could we uncover their remnants, hidden in the deepest parts of the galaxy, waiting to be found? The possibility that we are not the first, but perhaps the latest in a long line of civilizations to rise and fall within the Milky Way, is both humbling and awe-inspiring. It raises the question, if we do find evidence of these ancient civilizations, what will it mean for our understanding of history, time, and our own future in the stars? As we continue our search for life in the galaxy, we must also turn our attention inward to the possibility that the key to understanding extraterrestrial life may lie in the past. The remnants of civilizations older than our own, hidden within the Milky Way, could be the missing link that connects us to the broader narrative of life in the universe. The mysteries of the Milky Way are far from over. In fact, they may be just beginning to unfold. As we look deeper into the cosmos, we may find that the search for life is not just about finding new worlds, but about discovering the ancient echoes of civilizations that once looked up at the stars, just as we do today. The future of space exploration may not just be about discovering new planets. It could be about unlocking the secrets of the past and understanding what came before us. In doing so, we may find that the Milky Way holds far more than just the potential for life. It may hold the answers to questions that have plagued humanity for millennia. The universe is vast, and its secrets have long been hidden from our eyes. For centuries, we have looked up at the stars with wonder, but only in recent decades have we begun to peer deeper into the cosmic abyss with the help of advanced technology. With each new telescope, humanity's understanding of the universe grows, but even as we push the boundaries of space exploration, we're faced with the realization that there's so much more to uncover. And now, with the arrival of the next generation of telescopes, a new era of discovery is upon us. Perhaps the most eagerly anticipated of these instruments is the James Webb Space Telescope. Launched in December 2021, JWST is designed to peer deeper into the universe than any of its predecessors, including the Hubble Space Telescope. Positioned nearly 1.5 million kilometers from Earth, JWST can observe infrared light, something invisible to the human eye and far beyond the reach of most telescopes. This allows it to see through cosmic dust clouds and peer into the hearts of distant galaxies, exoplanets, and even the very early universe, just moments after the Big Bang. For the first time, we will be able to capture images of objects that were once thought to be beyond our reach, revealing new insights into the formation of stars, planets, and galaxies. But JWST is not the only instrument poised to expand our understanding of the cosmos. In the coming years, next-generation radio telescopes, such as the Square Kilometre Array, SKA, will come online, opening up entirely new avenues of discovery. These radio telescopes will be capable of detecting faint signals from across the galaxy, including those from the earliest stages of galaxy formation, as well as enigmatic phenomena like fast radio bursts, FRBs. SKA's vast array of antennas will span across continents, allowing scientists to observe the universe with unparalleled clarity and precision. With these revolutionary new telescopes, the galaxy and the universe at large are no longer just distant points of light in the sky. They are intricate, detailed, and filled with mysteries we are just beginning to unravel. What will these tools reveal about the Milky Way's spiral arms, the black holes that lurk at its core, and the countless exoplanets that could harbor life? As we peer deeper into the cosmic void, we will undoubtedly discover phenomena that challenge everything we thought we knew about the universe. What will these revolutionary new telescopes reveal about the universe, and how will they change our understanding of the Milky Way forever? The possibilities are endless. New stars, new planets, perhaps even signs of extraterrestrial life could soon be within our grasp. For the first time, we may glimpse the hidden corners of the galaxy that have eluded us for centuries. And in doing so, we could uncover the very secrets of our cosmic origins. As these new telescopes take their place in the search for knowledge, we find ourselves on the precipice of an entirely new chapter in the exploration of space. And with that comes a deeper curiosity. What other mysteries does the Milky Way hold? And what will humanity's next steps be as we push forward into the unknown? For centuries, the stars have been a symbol of mystery, inspiration, and the limitless possibilities of the human spirit. From the ancient astronomers who gazed up at the night sky, to the modern scientists who launch spacecraft to explore distant worlds, humanity has always been driven by a deep-seated desire to explore the unknown. Yet, despite all our advancements, we remain earthbound, looking up with longing. But that might soon change. The dream of interstellar travel, once confined to the realm of science fiction, is beginning to take shape in the real world. NASA's Artemis program, which aims to return humans to the moon by 2024, is just the first step in humanity's grand ambition to venture into space. But beyond the moon lies the next great frontier, Mars. With the successful deployment of rovers like Perseverance and the planning of manned missions, Mars is no longer a distant dream. It is the next logical target in humanity's quest to expand beyond Earth and establish a permanent presence on another planet. But even Mars, as challenging as it may be, is just a stepping stone. As we look further into the future, the true goal of space exploration becomes clear: interstellar travel. The idea of sending humans to other star systems, perhaps to exoplanets that orbit stars millions of light-years away, has tantalized scientists for years. However, the technological hurdles are immense. Speed, distance, and fuel constraints are just a few of the obstacles that stand in the way. One possible solution lies in advanced propulsion systems. Scientists are exploring concepts like nuclear fusion and antimatter engines, which could, in theory, propel spacecraft to speeds never before imagined. These propulsion methods could drastically reduce the time it takes to reach distant star systems, making interstellar travel a feasible reality in the distant future. But these technologies are still in their infancy, and much research remains to be done before they become practical. What if humanity's future lies not on Earth, but in the stars? What will it take to make that leap? The vision of a future where humans travel between stars, colonize new worlds, and encounter other civilizations is both awe-inspiring and humbling. But the journey to the stars will require not just technological innovation, but also a shift in our thinking about our place in the universe, our survival, and our responsibility to the cosmos. Beyond the technological challenges, there are philosophical questions to consider. What does it mean for humanity to leave behind the only home we've ever known? What kind of civilization will we become as we spread across the stars? And how will our new colonies change us? These questions are as important as the technology itself, and they shape the direction of humanity's future in space. The journey to the stars has already begun, and each step brings us closer to the impossible becoming possible. As we continue to develop faster spacecraft and explore new propulsion methods, humanity's reach will extend further into the Milky Way. The future of space exploration holds the promise of new worlds, new frontiers, and the discovery of civilizations or phenomena we cannot yet imagine. For centuries, the stars have been a symbol of mystery, inspiration, and the limitless possibilities of the human spirit. From the ancient astronomers who gazed up at the night sky, to the modern scientists who launch spacecraft to explore distant worlds, humanity has always been driven by a deep-seated desire to explore the unknown. Yet, despite all our advancements, we remain earthbound, looking up with longing. But that might soon change. The dream of interstellar travel, once confined to the realm of science fiction, is beginning to take shape in the real world. NASA's Artemis program, which aims to return humans to the moon by 2024, is just the first step in humanity's grand ambition to venture into space. But beyond the moon lies the next great frontier, Mars. With the successful deployment of rovers like Perseverance and the planning of manned missions, Mars is no longer a distant dream. It is the next logical target in humanity's quest to expand beyond Earth and establish a permanent presence on another planet. But even Mars, as challenging as it may be, is just a stepping stone. As we look further into the future, the true goal of space exploration becomes clear: interstellar travel. The idea of sending humans to other star systems, perhaps to exoplanets that orbit stars millions of light-years away, has tantalized scientists for years. However, the technological hurdles are immense. Speed, distance, and fuel constraints are just a few of the obstacles that stand in the way. One possible solution lies in advanced propulsion systems. Scientists are exploring concepts like nuclear fusion and antimatter engines, which could, in theory, propel spacecraft to speeds never before imagined. These propulsion methods could drastically reduce the time it takes to reach distant star systems, making interstellar travel a feasible reality in the distant future. But these technologies are still in their infancy, and much research remains to be done before they become practical. What if humanity's future lies not on Earth, but in the stars? What will it take to make that leap? The vision of a future where humans travel between stars, colonize new worlds, and encounter other civilizations is both awe-inspiring and humbling. But the journey to the stars will require not just technological innovation, but also a shift in our thinking about our place in the universe, our survival, and our responsibility to the cosmos. Beyond the technological challenges, there are philosophical questions to consider. What does it mean for humanity to leave behind the only home we've ever known? What kind of civilization will we become as we spread across the stars? And how will our new colonies change us? These questions are as important as the technology itself, and they shape the direction of humanity's future in space. The journey to the stars has already begun, and each step brings us closer to the impossible becoming possible. As we continue to develop faster spacecraft and explore new propulsion methods, humanity's reach will extend further into the Milky Way. The future of space exploration holds the promise of new worlds, new frontiers, and the discovery of civilizations or phenomena we cannot yet imagine. Far from the familiar twinkling stars we gaze upon at night, the Milky Way holds dangers so immense and incomprehensible they defy the very fabric of space and time. These are the cosmic hazards that can shape the galaxy in violent, unpredictable ways: black holes, supernovae, and other cataclysmic events that lurk in the depths of space. What if there are invisible forces in the Milky Way that could wipe out entire civilizations without warning? Forces that exist on a scale so far beyond our everyday experience, we can barely comprehend them. Black holes, with their irresistible gravitational pull, are among the most dangerous entities in the universe. These are not just distant objects in space. They are points where space and time lose all meaning. A black hole is formed when a massive star collapses under its own gravity, creating a singularity, an infinitely dense point where not even light can escape. It is here, in the heart of a black hole, that the laws of physics, as we understand them, break down. But the real danger comes from the region surrounding the black hole, the event horizon. Once you cross it, escape is impossible, and time itself begins to behave strangely, stretching out and warping in ways we can hardly grasp. Within the Milky Way, there are many supermassive black holes, including the one at the very center of our galaxy, Sagittarius A*. This black hole holds the mass of millions of suns, but it doesn't stop there. There are potentially billions of others scattered across the galaxy. The gravitational influence of these black holes can be catastrophic, pulling in anything that ventures too close, from dust and gas to entire stars. And while these black holes are often located far from Earth, their reach extends beyond their immediate vicinity, shaping the galaxy in ways we cannot see. What would happen if a black hole's reach were to extend far enough to threaten the very existence of a civilization? Supernovae, the explosive deaths of massive stars, are another cosmic hazard that shapes the Milky Way. When a star runs out of fuel, it undergoes a violent explosion, releasing an enormous amount of energy and scattering elements across the galaxy. These explosions are so powerful that they can briefly outshine an entire galaxy. But more than just providing the elements for the birth of new stars, supernovae also emit deadly radiation that can travel vast distances. A nearby supernova could potentially shower the Earth with radiation, disrupting our atmosphere, wiping out life, and altering the course of evolution. These events, though rare, are among the most violent occurrences in the universe, capable of reshaping entire regions of space and life within them. As scientists peer deeper into the Milky Way, they are constantly uncovering new black holes and supernova remnants, piecing together the puzzle of these violent cosmic events. The truth is that our galaxy is filled with dangers we can't even see, and understanding these cosmic hazards is just the beginning. What if these forces are not just distant threats, but active players in the drama of galactic life and death? With each new discovery, we come closer to understanding how black holes and supernovae shape the Milky Way, and whether they might one day reach far enough to threaten us. In the vast reaches of the Milky Way, where stars are born and die, there are objects that defy everything we think we know about planetary systems. These are rogue planets, planets that drift through space without being bound to any star. Unlike the familiar planets in our solar system, which orbit the Sun, rogue planets wander the galaxy, isolated and adrift, their existence a cosmic mystery. What if the most dangerous object in the Milky Way is an invisible, wandering planet that could cross our path? Rogue planets are not just strange anomalies. They represent a completely different way of thinking about planetary systems. Scientists believe that these planets may form in the same way as regular planets, but instead of settling into stable orbits around stars, they are ejected into space. Some rogue planets may have formed around distant stars before being cast out into the cold void, while others may have been born in isolation, drifting aimlessly through the galaxy. One of the most intriguing questions about rogue planets is whether they could harbor life. Without a parent star to provide warmth and energy, how could a rogue planet support life as we know it? However, there are potential scenarios where life could exist on such a planet, perhaps deep beneath its surface, where geothermal energy from the planet's core could provide warmth. In the dark, frozen expanse of space, life could take forms that we cannot even begin to imagine, hidden from the prying eyes of telescopes. But the dangers posed by rogue planets extend beyond their potential for harboring unknown life. Because they are not tethered to a star, rogue planets can travel vast distances through the galaxy, unimpeded by the gravitational constraints that bind planets in solar systems. This makes them difficult to track and predict. What if a rogue planet, hurtling through the galaxy at unimaginable speeds, crossed the orbit of our solar system? It would be nearly impossible to detect until it was too late. The gravitational forces of such a planet could disrupt the delicate balance of our solar system, destabilizing the orbits of planets and perhaps even causing catastrophic collisions. The existence of rogue planets forces us to reconsider everything we know about planetary systems. Are these planets just relics of failed star systems? Or could they represent an entirely new class of cosmic objects, harboring unknown life or dangerous potential? What if one of these rogue planets were headed directly for us, and we had no way to stop it? The eerie nature of rogue planets reminds us that even in the most familiar parts of space, there are mysteries waiting to be uncovered. These nomadic worlds represent an enigma, an object in the galaxy that we cannot predict or control. As we continue to explore the Milky Way, we may find that the dangers we thought we understood are far more unpredictable and terrifying than we ever imagined. Beyond the black holes, supernovae, and rogue planets that roam the Milky Way, there are other threat forces that could reach out from the dark corners of space and change life as we know it, without any warning. Gamma-ray bursts are among the most powerful and mysterious of these dangers, capable of unleashing energy so intense that it could wipe out entire civilizations with a single flash. What if a gamma-ray burst could destroy life on Earth, and we wouldn't even see it coming? A gamma-ray burst is a brief but immensely powerful explosion that releases a torrent of high-energy radiation. These bursts occur when massive stars collapse into black holes, or when two neutron stars merge, creating a burst of energy that can outshine an entire galaxy for a few seconds. GRBs are so intense that, if one were to occur close enough to Earth, the radiation could strip away our atmosphere, causing mass extinctions and disrupting the delicate balance of life on our planet. The good news is that GRBs are relatively rare and typically occur in distant galaxies. The bad news is that we have no way of predicting when or where the next burst will occur. The closest one could be light years away, or it could be lurking just around the corner, ready to unleash its destructive power. What makes GRBs even more terrifying is their unpredictability. Unlike supernovae, which we can observe as they unfold, GRBs occur so suddenly and so briefly that we may not even have time to detect them until they've already passed. The radiation they emit travels across space at the speed of light, leaving no time for warning. The sheer force of a gamma-ray burst could decimate everything in its path, altering the course of evolution or wiping out entire ecosystems in an instant. But GRBs are not the only hidden dangers lurking in the universe. Cosmic rays, high-energy particles traveling at nearly the speed of light, are another potential threat to life in space. While Earth's atmosphere and magnetic field protect us from the worst of these rays, astronauts and spacefaring species may not be so lucky. In the vacuum of space, cosmic rays are a constant and invisible danger, capable of damaging DNA and causing mutations. In large enough doses, they could be fatal, making space travel an even more hazardous endeavor. As we continue to explore the Milky Way, we are faced with the reality that the universe is not a safe, predictable place. The threats we face come from forces we cannot control, forces that could reach out from the dark void of space and alter the course of life in an instant. But as daunting as these cosmic dangers may seem, they are part of the greater mystery of the universe. Understanding them is the first step in protecting ourselves from their potentially devastating effects. These hidden threats, from gamma-ray bursts to cosmic rays, remind us of the fragility of life in the Milky Way. As we push further into space and explore the vast expanse of the galaxy, we must remain vigilant. The dangers are real, and they are out there, waiting in the dark corners of space. But with every new discovery, we come closer to understanding how to survive in the face of these cosmic hazards, and perhaps one day, how to protect ourselves from them. Imagine standing at the edge of the universe, gazing into the infinite abyss. The stars twinkle, the galaxy spins in its spiral arms, and yet, within that vastness, there may be something we cannot see, a hidden reality just beyond our grasp. Could the Milky Way, the galaxy we call home, be just one of many galaxies in a grand, interconnected web of universes? What if the cosmos is far larger and more complex than we ever imagined, existing within a structure we cannot even begin to comprehend? The concept of alternate dimensions and parallel universes has captivated the human imagination for centuries. Yet it has only recently entered the realm of scientific speculation. According to theories like string theory and the multiverse hypothesis, our universe could be just one bubble in an ever-expanding sea of realities. String theory suggests that there could be many more dimensions hidden and beyond our ability to perceive, each with its own laws of physics. These dimensions could exist side by side with our own, intertwined in ways that we cannot detect with our current tools. In this speculative framework, the Milky Way could be part of a vast multiverse, a collection of universes, each with its own set of fundamental rules, stars, planets, and perhaps even forms of life. Some of these parallel universes might be strikingly similar to ours, with galaxies like our own orbiting stars that resemble our Sunday. But in other universes, the very laws of physics could be completely different. Could there be worlds where gravity works in reverse, where time flows differently, or where life has evolved in ways we cannot begin to fathom? What if the Milky Way is just one galaxy in a multiverse, where parallel universes are hidden just out of reach? The implications of this idea are mind-boggling. If the multiverse theory holds true, the very structure of reality could be far more complex and vast than we ever imagined. The galaxies we observe in the night sky, the stars we see shining brightly, may be part of a much larger cosmic landscape, an endless ocean of worlds, some of which could harbor life in forms that stretch the boundaries of our understanding. But what does this mean for the future of space exploration? If the Milky Way is only a small piece of the multiverse, then perhaps the next phase of our exploration won't just involve traveling to distant stars and planets within our galaxy. It could mean discovering pathways to other universes, learning to navigate realms where the rules we know no longer apply. This opens up the possibility of interacting with alternate dimensions, encountering beings or civilizations that exist in a reality parallel to ours, where the very fabric of existence is alien to anything we know. The search for life, for knowledge, and for answers could extend beyond our own universe, reaching into the realms of the multiverse. If parallel universes exist, they could hold the key to some of the deepest questions humanity has ever asked. What is our place in the grand scheme of existence? Are we just one of many civilizations scattered across countless realities? Or are we the first to gaze upon the stars, dreaming of what lies beyond? As we explore the possibility of alternate dimensions, we begin to realize that the journey of discovery may take us beyond the Milky Way, beyond the confines of our universe, and into realms we can scarcely imagine. This idea, while speculative, opens up new frontiers in space exploration, frontiers that might one day redefine everything we know about the cosmos. As humanity stands at the dawn of space exploration, our ambitions stretch far beyond the reaches of our planet. We've set our sights on the stars, on colonizing other worlds, and on becoming a spacefaring civilization. But the question remains, can we truly survive, thrive, and build a future beyond Earth? The vision of humanity's future in space is one of both hope and uncertainty, where the challenge of establishing human civilization in the vast, unforgiving expanse of the Milky Way may be our greatest undertaking. The first steps toward this future are already being taken. Space agencies around the world are working tirelessly to send humans to the moon again, with NASA's Artemis program aiming to establish a sustainable human presence on the lunar surface. This is just the beginning. The moon could become a stepping stone, a launch pad for deeper space exploration, and even a potential source of resources that could help fuel humanity's expansion across the solar system. But beyond the moon lies the next great challenge, Mars. Mars has long been the focus of space exploration efforts. Its proximity, coupled with the discovery of signs of past water and the possibility of a habitable environment, makes it the most viable candidate for human colonization. Yet the obstacles are formidable. The Martian atmosphere is thin, its surface is inhospitable, and the journey itself poses countless dangers. However, with advances in technology and space travel, the possibility of establishing a permanent human settlement on Mars is becoming increasingly realistic. But even that is just the beginning. As we look to the far future, the idea of terraforming, altering a planet's atmosphere and environment to make it more Earth-like, becomes a tantalizing prospect. Could we one day terraform Mars, turning it into a thriving, livable world for generations to come? And what about other planets, moons, and exoplanets scattered across the Milky Way? As spacefaring technology evolves, humanity could one day live on multiple worlds, spread out across the solar system, and perhaps even beyond. But this dream raises profound questions. What if humanity's survival depends not on Earth, but on our ability to thrive across the stars? As we venture farther into space, we may face the realization that Earth alone cannot sustain the ever-growing demands of humanity. Our planet, beautiful and abundant as it is, faces numerous challenges, from climate change to resource depletion. Expanding beyond Earth may not just be a dream, it could be a necessity for our survival as a species. The stars may hold the key to humanity's long-term future, providing new homes, new resources, and new opportunities for growth. But colonizing other worlds comes with its own set of challenges. There are not just technological barriers to overcome, but ethical and philosophical dilemmas to consider. What does it mean to be human in the vastness of space? What responsibilities do we have as we expand across the stars? And perhaps the most profound question of all, what does it mean to build a new civilization? One that is not bound to the constraints of a single planet, but exists across the galaxy. The future of human civilization in space is as uncertain as it is exciting. It could be a future where humanity becomes a multi-planetary species, expanding to new worlds, establishing thriving colonies, and unlocking the secrets of the cosmos. Or it could be a future where humanity faces the harsh realities of life beyond Earth, where survival is a constant struggle, and where the boundaries of what it means to be human are constantly tested. One thing is clear: our future lies among the stars, and the path ahead will be shaped by the decisions we make today. As we embark on this journey, we must ask ourselves, what kind of civilization will we become as we spread across the Milky Way? What lessons will we learn, and what legacy will we leave behind? The answers to these questions will not only define our future in space, but also shape the future of humanity itself. As we gaze into the vastness of the Milky Way, filled with billions of stars, each one a potential cradle for life, we are left with a fundamental question that has puzzled humanity for centuries. What is our purpose in the universe? In this seemingly infinite galaxy, teeming with mysteries, what significance do we hold as individuals? As a species, this question, which has echoed throughout history, transcends science and touches the very core of our existence. It is a question that intertwines science, philosophy, and spirituality. A question that remains as relevant today as it was when ancient civilizations first looked to the stars for answers. For thousands of years, humanity has sought to understand its place in the cosmos. Ancient cultures looked to the stars for guidance, creating mythologies and religions that connected the heavens to human life. The Greeks, for example, saw the gods as controlling the movements of the stars and planets. The idea that our lives were tied to the stars provided both a sense of purpose and a deep connection to something greater than ourselves. In many ways, the stars were seen as the divine order of the universe, and humanity's role was to align with that order, finding meaning in the cycles of the cosmos. As science progressed, particularly during the Renaissance, the view of humanity's role shifted from divine determinism to a more rational understanding of the universe. Copernicus, Galileo, and later Newton revealed that the Earth was not the center of the universe. Instead, we were just one small planet orbiting an ordinary star in an ordinary galaxy. This realization could have made our existence seem insignificant in the grand expanse of the cosmos. Yet, despite this, humanity continued to search for meaning, trying to understand how we fit into a universe so much larger than we had ever imagined. What if, despite the vastness of the Milky Way, humanity's search for meaning is written into the stars themselves. Could it be that our very existence, our need for purpose, is not just an emotional longing, but an intrinsic part of being human? As we look to the stars and wonder about our place in the galaxy, we may find that this search for purpose is not something we have to create, but something that has always been part of us. The Milky Way, with its millions of stars, could be the perfect metaphor for our journey. Vast, mysterious, and yet somehow calling us toward discovery. This need for purpose transcends beyond ancient beliefs, or even scientific understanding. It is woven into the fabric of who we are. It's why we look to the stars for answers, why we search for life beyond our world, why we dream of reaching other planets. The desire to know if we are alone, to understand if there is something greater than us in the universe, is a driving force in our quest for meaning. It speaks to the very heart of our existence, our need to connect, to discover, and to belong. In the future, as space exploration reaches new heights, this search for purpose will only intensify. The more we uncover about the Milky Way, the more questions will arise. What is our place in the vastness of space? Are we part of something larger? Are we the product of chance or design? These questions, which have driven humanity for centuries, will continue to guide us in our exploration of the cosmos. As we seek answers, we are also discovering more about ourselves. The journey into space is not just a physical one, but a deeply existential one that challenges us to reconsider our place in the universe. As we look to the stars and wonder about our role in the grand scheme of things, the next step is to explore the very nature of existence itself. How do we understand the passage of time, the very fabric of reality, and how does that change the way we view our existence? What if, in seeking the answers to these questions, we are not just uncovering the mysteries of space, but also the mysteries of our own human nature? Time so constant, so familiar, and yet, when viewed through the lens of the cosmos, it becomes one of the most perplexing and elusive concepts in our understanding of reality. In the context of the Milky Way, space and time are not merely physical constructs, they are malleable, and how we perceive them may be far different from how they truly operate. We often think of time as a steady, unchanging flow, a simple progression from past to present to future. But what if time, as we experience it, is only one layer of reality? What if, in the vastness of space, time itself behaves in ways we can't even begin to comprehend? One of the most profound revelations of modern physics is Albert Einstein's theory of relativity, which showed that time is not a fixed, universal constant. Instead, it is relative. It changes depending on your speed and the strength of gravity around you. This was a groundbreaking discovery that opened the door to a whole new understanding of the universe. What we think of as time is fluid, influenced by the warping of space-time itself. In the presence of a black hole, for example, time slows to a crawl. This means that time in one part of the Milky Way could move at a completely different pace than in another. The implications of this are staggering. If we could travel near the speed of light, we would experience time differently, perhaps allowing for what we might call time travel. What if time, as we understand it, is merely an illusion, a construct of our minds to make sense of the world around us? Could the passage of time be a dimension that we simply don't perceive in its full complexity? If time can be warped and stretched by gravity, could it also be something we can transcend? In a universe where space-time is bent and twisted by the forces of black holes, neutron stars, and cosmic radiation, could time itself eventually become irrelevant to those who master the forces of space? The idea of transcending time and space is one of the most tantalizing and speculative aspects of human existence. If time is not as fixed as we believe, what does that mean for our future in space? Could we, as a species, evolve in a way that allows us to navigate through time itself? Perhaps in a future where we've harnessed the power of space and time, we could visit other eras of the universe, experience distant moments, and witness the birth and death of stars, or even whole galaxies. As we begin to explore these philosophical questions, we realize that time is more than just a background element of our existence. It is an active, dynamic force that shapes our future and our understanding of the cosmos. Our perception of time will shape how we approach space exploration. If we understand time as something more fluid and bendable, then perhaps the barriers to interstellar travel and communication could be broken down, and the entire galaxy could be within reach. What if, in the future, humanity is not confined to linear time, but has found a way to break through its constraints? Could the future of space exploration involve a deep understanding of time travel, allowing us to visit parallel dimensions, jump across epochs, or even alter the course of our own history? These possibilities open up not only scientific questions, but existential ones. What does it mean for us as human beings if time itself can be traversed? The mysteries of time naturally lead to broader reflections on our place in the universe. If we are able to transcend time and space, how will that change our understanding of existence? The answers to these questions might define not just the future of human civilization, but the very nature of what it means to be human in the Milky Way and beyond. As we continue our exploration of space, our understanding of time will deepen, and with it, the possibilities of our future. The exploration of time may one day become just as crucial as the exploration of space itself, allowing us to journey through not only the stars, but the very fabric of reality. As we venture deeper into the Milky Way, crossing the great expanse of stars and planetary systems, a question inevitably arises: what will humanity leave behind? For all of our advancements, our explorations, and our technological marvels, the idea of legacy weighs heavily on our minds. The possibility of becoming a multi-galactic civilization stretching across the stars raises both awe and concern. The potential for humanity's legacy to be scattered not just across Earth, but across the vast reaches of the galaxy is a notion both humbling and profound. Imagine a future where Earth is remembered not as the sole cradle of humanity, but as the birthplace of a civilization that transcended its home planet. In this future, the Milky Way itself becomes a testament to human exploration, a galaxy shaped by our ambitions and actions. Perhaps humanity's legacy will be marked not just by the physical artifacts we leave behind, satellites, spaceships, or even the remnants of colonies, but by the ideas and knowledge we share with the galaxy. Our discoveries about the stars, the planets, and the mysteries of the cosmos could become the building blocks of a new galactic culture, where the wisdom of countless civilizations builds upon the foundations laid by our species. But what does it mean for humanity to leave such a legacy? In our search for meaning and survival, we will inevitably encounter other life forms, perhaps more advanced, perhaps entirely different from anything we could imagine. As we reach for the stars, we must ask, do we have a responsibility to protect the galaxy from harm, to share our knowledge, and to ensure that the universe remains a place where life can flourish, not just for ourselves, but for all beings? This question, while deeply philosophical, also carries profound moral implications. If we are to spread across the stars, colonizing planets, and establishing outposts on distant moons, what role will we play in the grand cosmic tapestry? Are we the protectors of the galaxy, stewards of a future that spans countless worlds, or will we become another destructive force in the cosmos, leaving behind a trail of exploitation and ecological ruin? The answers to these questions will shape not only how we explore the Milky Way, but also how we view ourselves within it. What if humanity's true legacy isn't bound to Earth, but scattered across the Milky Way, waiting to be discovered? This thought stirs a sense of wonder and responsibility. Could future civilizations, whether human or alien, look back and discover the remnants of our journeys? What will they find? Perhaps it will be the traces of our scientific breakthroughs, the records of our culture, or the still burning embers of our colonies scattered across distant worlds. But just as likely, they might encounter the silent echoes of humanity's former presence, a civilization that once dreamed of the stars, only to leave behind faint traces of its ambitions. This exploration of legacy forces us to confront the deeper questions of what it means to be human in a universe so vast. It beckons us to think beyond the boundaries of our own planet and reflect on the larger role we play in the cosmos. Are we simply the products of chance, floating in the endless void of space, or do we have a deeper purpose that connects us to the galaxy at large? As we leave our mark across the Milky Way, will we be remembered as the species that expanded its reach to the stars, sharing knowledge and fostering peace? Or will we be seen as an ambitious, reckless civilization that overstepped its bounds? As we consider our legacy, we must also reflect on the responsibilities we carry. With every new step we take into the unknown, we must ask ourselves, what will we leave behind? Will it be a legacy of exploration, wisdom, and harmony? Or will it be one of destruction, neglect, and hubris? These questions don't just belong to future generations. They are questions we must begin answering now, as we chart the course for humanity's future in the stars. The answers to these questions are not just philosophical. They have real implications for how we navigate our journey into the Milky Way. The legacy we create in space will shape the future of humanity, as well as our relationship with the galaxy itself. As we continue our exploration of the cosmos, we will encounter the vast unknown, and in doing so, we will define not just our future, but our place in the infinite expanse of the universe. This journey into the Milky Way, full of both discovery and uncertainty, naturally brings us to the next chapter. The challenges and opportunities humanity will face as we continue to explore and expand into the unknown. As we embark on this journey, our legacy will be tested, and our choices will determine what kind of civilization we will become. In the end, the galaxy may hold the answers to questions that have haunted us for centuries, and it is up to us to decide how we wish to be remembered across the stars. The Milky Way, a vast and swirling dance of stars, gas, and dust, holds countless secrets yet to be uncovered. While astronomers have mapped much of our galaxy, large portions remain shrouded in mystery, hiding just beyond the reach of our most powerful instruments. There are regions within the Milky Way, so distant, so obscured by interstellar dust, that they elude even the most advanced telescopes. These uncharted territories remain the final frontiers of our galaxy, waiting to be explored by future generations of explorers. One such area is the outer rim of the Milky Way, a region on the galaxy's edge, far from the bright, bustling center where the majority of stars are concentrated. This part of the galaxy is difficult to study because of its distance and the fact that much of it lies in the plane of the galaxy, obscured by dense clouds of gas and dust. Our view of this area is limited, and much of the matter in this region is invisible to conventional telescopes. Yet, what could lie in this distant zone? Could there be hidden star systems, planets, or even remnants of ancient civilizations scattered across the outer edges of the galaxy, waiting to be discovered? Perhaps even more perplexing are the areas dominated by dark matter, a mysterious substance that makes up a large portion of the Milky Way's mass, but cannot be seen directly. Dark matter does not emit, absorb, or reflect light, making it completely invisible to our eyes. It only interacts with visible matter through gravity. The sheer weight of dark matter shapes the structure of the galaxy itself, forming invisible spokes that help bind the stars in place. But despite its influence, dark matter remains largely undetectable. What could we discover if we could finally glimpse its true nature? What hidden objects or phenomena might dark matter conceal from our view? We often imagine the Milky Way as a familiar spiral, its stars and nebulae dancing in an ordered pattern. But in truth, the galaxy is far more complex. As we push further into these uncharted regions, the possibilities multiply. Could there be entire galaxies floating in the cosmic darkness beyond the Milky Way, captured by the galaxy's gravity, yet hiding in plain sight? The existence of rogue stars and wandering black holes in the galaxy hints that there are forces at play, far beyond what we can perceive, waiting to be uncovered. What if entire star systems, or even civilizations, are hidden from us, waiting to be discovered by future explorers? The idea of lost worlds, unseen due to the limits of our technology, is not just a romantic notion, it could be a scientific reality. New technologies and methods, such as gravitational wave detection or advanced infrared imaging, may soon allow us to peer deeper into the galactic fog, revealing regions of space that were once beyond our reach. As humanity pushes the boundaries of space exploration, we are sure to encounter regions of the Milky Way that challenge everything we know about the universe. With future advancements in space travel and observational technology, we will be able to reach these uncharted territories, not just mapping them, but uncovering the profound mysteries that lie hidden within them. The journey into these unknown regions is one of discovery, one that will redefine our understanding of the galaxy and, perhaps, our place within it. The future of space exploration is not just about sending humans into the unknown. In the coming decades, artificial intelligence, AI, will play a central role in humanity's efforts to explore the Milky Way, assisting in tasks that are simply beyond human capability. From analyzing distant exoplanets to navigating spacecraft across vast distances, AI is poised to become an indispensable tool in the pursuit of knowledge about the cosmos. AI's role in space exploration is already becoming apparent. For example, AI systems are used to monitor spacecraft, manage data, and even assist in the discovery of exoplanets. By sifting through vast amounts of data, AI can identify patterns and anomalies that would take humans years to notice. AI algorithms can also analyze the composition of distant stars, measure the orbits of planets, and even predict the behavior of galaxies. These machines, far faster and more efficient than any human team, allow us to gain insights into the universe at an unprecedented rate. But AI's potential goes beyond analysis. In the future, autonomous AI systems could be responsible for piloting spacecraft on long-duration missions, perhaps to star systems light years away. This would eliminate the need for constant human control, allowing explorers to send missions that are independent, self-sustaining, and capable of making decisions in real time. Such missions could explore the outer regions of the galaxy, investigating phenomena that would otherwise remain out of reach. One of the most exciting possibilities is the idea of AI-assisted discovery in the most remote and dangerous areas of space. From studying black holes and dark matter to searching for signs of extraterrestrial life, AI could uncover new realms of space that we have not even begun to comprehend. These AI systems could be sent to locations where human presence is not feasible due to distance, danger, or harsh environments, giving us the ability to explore without limitations. However, the rise of AI in space exploration raises significant questions about the future of humanity in space. What happens when machines surpass human capabilities? When AI systems become more efficient than humans at solving problems or conducting experiments, will we still need to send astronauts at all? The ethical implications of autonomous space exploration also need consideration. What responsibility do we have for the AI systems we create? If these machines become self-aware or take actions that impact other civilizations or environments, who is accountable? The increasing reliance on AI could also change the way we view our role in the universe. As we send autonomous explorers to other planets and galaxies, our sense of ownership over the cosmos may diminish, replaced by a realization that much of space is better suited for machines than for human beings. And yet, these machines will carry our hopes, our curiosity, and our need to understand the universe. In a way, AI will become our ambassadors in space, our emissaries to the stars. AI's role in space exploration will be one of expansion and discovery, unlocking the doors to realms beyond our imagination. As these systems grow more capable, they will push us further into the Milky Way and beyond, revealing new wonders and perhaps new mysteries. The future of space exploration will be shaped by the harmonious cooperation between humans and artificial intelligence, marking the beginning of a new era in the search for the unknown. As humanity continues its journey into space, The challenges we face are not just technical, they are physical, psychological, and existential. The deep, cold void of space is a harsh, unforgiving environment, and venturing into it poses profound risks. To explore the stars, humanity must not only conquer the vast distances, but also endure the toll that long-term space travel will take on both our bodies and minds. Cosmic radiation is one of the most insidious dangers. Far from the protective shield of Earth's atmosphere and magnetic field, space travelers will be exposed to high-energy particles that can damage cells and DNA. Long-term exposure to cosmic radiation could lead to serious health problems, including cancer and genetic mutations. While spacecraft can be equipped with shielding to reduce radiation exposure, it is a challenge that has no simple solution, and the risk increases as we venture farther from Earth. Beyond the physical dangers, space presents psychological challenges that could prove even more insidious. The isolation of deep space travel, where astronauts are cut off from Earth for years at a time, could lead to severe mental health problems. Loneliness, lack of social interaction, and the strain of confinement can have debilitating effects on the human psyche. Crew members will need to rely on each other to maintain morale and sanity, but this may not always be enough to counter the immense psychological toll of living in a tiny, artificial environment with no escape. The immense distances involved in space travel also pose a unique challenge. Even the closest star systems are light years away, and current spacecraft travel at speeds far too slow to make interstellar travel practical within a human lifetime. Propulsion technologies, such as nuclear fusion or antimatter engines, must be developed to reach these distant systems. However, the technological hurdles are enormous, and we are still far from achieving the speeds necessary to travel to other stars within a reasonable time frame. In addition to these challenges, there is the question of life support. Spacecraft must be equipped with advanced systems that provide everything needed for human survival: oxygen, water, food, and waste disposal. These systems must be self-sustaining for long periods, as resupplying spacecraft far from Earth is impractical. Developing closed-loop ecosystems, where astronauts can grow their own food and recycle resources, will be essential to ensuring survival during long-duration missions. But as daunting as these challenges are, they are not insurmountable. Advances in medical technologies, space habitats, and artificial intelligence could help overcome many of these obstacles. Space agencies around the world are already working on solutions to protect astronauts from radiation, improve psychological resilience, and develop technologies that will make deep space exploration a reality. Yet, for all the innovations and solutions, space travel remains a dangerous endeavor. The harshness of space, its vast emptiness, the radiation, the isolation, cannot be denied. But humanity's innate drive to explore, to push beyond the limits of the known, will continue to propel us forward. The greatest challenge of space travel may not be the distance we must travel, but the toll it takes on the human spirit. And as we embark on this journey, we must ask ourselves, are we ready for the challenges that await us in the infinite unknown? For millennia, humanity has gazed toward the stars, dreaming of what lies beyond our world. The promise of space exploration is nothing less than a new frontier, a vast, uncharted wilderness where the possibilities are as limitless as the universe itself. It is the next great chapter in the human story, one filled with promise, adventure, and an opportunity to ensure the survival of our species. Throughout history, humanity has always sought new frontiers. Whether it was the exploration of the oceans, the discovery of new lands, or the conquest of the skies, the human spirit has been driven by the innate desire to push boundaries and expand beyond the known. These endeavors have shaped civilizations, forged new paths, and ultimately ensured that humanity would continue to thrive. Now, space represents the greatest frontier of all, a vast expanse that holds the key to humanity's future. What if space isn't just the final frontier? It's the next step in humanity's evolution. Space holds the potential for us to become more than what we are. The resources of the Moon, Mars, and beyond could provide the materials necessary to build a sustainable future, alleviating the pressures we face on Earth. New technologies could be born from the challenges of space, from advancements in energy production to breakthroughs in medicine. Space could unlock new scientific discoveries that change the way we understand the universe, and perhaps even our place within it. The possibilities are staggering. With the promise of new worlds to explore and new habitats to settle, humanity could evolve into a multi-planetary species. Colonizing the Moon or Mars would be just the beginning, with humanity potentially reaching far-off exoplanets in the distant future. The knowledge gained through space exploration could transform our understanding of life itself, revealing new forms of existence or offering insights into the origins of life on Earth. This optimistic view of space is deeply rooted in the human spirit of exploration. It's a continuation of the journeys of the past, whether that was the age of discovery on Earth or the space race that captivated the world in the mid-23rd century. The promise of space represents a future in which humanity does not simply survive, but thrives, adapting to new environments, innovating in unimaginable ways, and ensuring that the lessons learned from our time on Earth guide our future in the cosmos. Yet, even as we look toward this new frontier with hope and excitement, there are challenges ahead. The vastness of space, its inhospitable nature, and the unknown dangers that lie beyond our atmosphere are all real threats that must be overcome. As we chart this new course, we must be mindful of the consequences of our actions. For while space offers a new beginning, it also brings with it the weight of responsibility. As we prepare to venture into the unknown, we must remember that space is not only a place of possibility, it is also a place of danger. In the next section, we will explore the darker side of humanity's quest to conquer the stars, where the dangers of overextending ourselves in space could threaten the very future we seek to build. As the excitement of space exploration builds, so too does the awareness of the inherent risks that come with venturing into the great unknown. The promise of new frontiers and untapped resources is alluring, but the pursuit of these opportunities raises significant dangers. The vastness of space is not only filled with potential, but with challenges that could lead to our greatest peril. As we push further into the cosmos, we must ask, could humanity's ambition to conquer space lead us to destroy ourselves in the process? One of the primary dangers of space exploration is the exploitation of resources. While the Moon and Mars hold promise for providing the raw materials necessary for future generations, the unchecked exploitation of these worlds could lead to unintended consequences. Mining operations, if not carefully managed, could disrupt the delicate balance of these environments. Just as industrialization on Earth has impacted our own planet's ecosystem. If humanity moves forward in a way that mirrors past mistakes, we could repeat the patterns of destruction we have seen on Earth, creating a future where we exhaust our resources in space, just as we did on our home planet. The risks of contamination also pose a serious threat. As we explore other planets and moons, we must be cautious not to introduce earthly microorganisms that could contaminate other ecosystems. The idea of planetary protection is now a key part of space exploration, but as missions to Mars and beyond increase, the chances of cross-contamination grow. What if we unknowingly bring harmful bacteria or viruses to distant worlds, wiping out potential forms of alien life before we even realize it? Conversely, what if life from these distant worlds reaches Earth, carrying unknown pathogens that could harm our planet's delicate biosphere? The dangers of overextending ourselves in space also involve the possibility of conflict. As more nations, private companies, and even individuals begin to stake claims in space, the potential for space-based conflicts increases. The Moon, for example, could become a battleground for resources, with competing interests vying for control over valuable locations or assets. Space is a vast and unforgiving environment, and the pressures of expansion could lead to geopolitical tensions that we are not fully prepared to handle. Just as we have struggled with territorial disputes on Earth, we may find ourselves fighting over new territories in the stars. What if humanity's ambition to conquer space leads us to our greatest peril? destroying ourselves in the process. The desire to explore the unknown and push the limits of human achievement is undeniable, but it must be tempered with caution and respect for the fragile nature of both space and our own civilization. The future of humanity in space will depend not only on our technological capabilities, but on our wisdom and our ability to navigate the ethical and environmental challenges that lie ahead. As we venture further into space, we must ask ourselves how far we are willing to go, and whether the risks of overextending ourselves are worth the rewards. The pursuit of knowledge and expansion must be balanced with responsibility, and the decisions we make in the coming years will shape the future of our species. In the final section of this chapter, we will reflect on humanity's fate in the Milky Way, considering whether our survival in space will be a story of triumph or tragedy. Will we rise to the challenges and thrive, or will we falter under the weight of our own ambition? The fate of humanity in the stars is still to be determined, but the choices we make today will decide our future. As humanity stands on the threshold of interstellar exploration, the question of our ultimate fate looms large. Will we thrive as a multiplanetary species, venturing from star to star, building new civilizations and discovering new forms of life? Or will our ambition, our inability to address the risks, and our internal conflicts lead us to extinction, becoming yet another failed experiment in the vast timeline of the universe? The promise of space exploration is boundless. It offers a future where humanity no longer depends solely on Earth, but instead spreads across the Milky Way, taking its place among the stars. Colonizing planets like Mars, establishing outposts on moons, and harnessing resources from distant asteroids could provide humanity with the means to survive beyond the confines of our home planet. This vision offers hope that we can escape the confines of Earth's environmental crises, geopolitical conflicts, and resource limitations. But there is a darker side to this vision. Space is vast, but it is also incredibly harsh. The dangers we face, cosmic radiation, the vacuum of space, and the isolation of long-duration travel are but the beginning. As we push into the stars, we must face the possibility that we may not be prepared for the challenges that lie ahead. Humanity has always had the capacity for conflict, and as we expand across the galaxy, there is the risk that we may bring our wars, greed, and divisions with us. Furthermore, the ethical dilemmas surrounding space exploration and colonization cannot be ignored. As we expand into space, we must question whether we have the right to claim other worlds as our own, to exploit their resources, or to alter their environments. What happens when we encounter other life forms? Do we have a responsibility to protect them, or will we repeat the mistakes of Earth, exploiting and destroying in the name of progress? Will humanity's future in the Milky Way be one of triumph or tragedy? The choice is ours to make. As we look to the stars, we must ask ourselves whether we have the wisdom to overcome the challenges of space and the moral courage to ensure that our expansion does not come at the cost of our humanity. The fate of our species rests not just on our technological achievements, but on our ability to navigate the complexities of existence in a vast, unpredictable universe. As we continue our journey into space, we must remember that survival is not guaranteed. The universe is indifferent, and space is a dangerous frontier. But within this unknown lies the possibility for something truly remarkable, the chance to thrive, to evolve, and to find our place among the stars. The fate of humanity in the Milky Way is not yet written, but it is ours to determine. The choices we make today will echo through the stars for generations to come. The vastness of the Milky Way is awe-inspiring, but all things, no matter how magnificent, must eventually come to an end. As we gaze upon our galaxy, it is easy to imagine its beauty as eternal, an endless swirl of stars and cosmic wonders. Yet, the reality is that the Milky Way, like all galaxies, will not remain the same forever. What if the Milky Way is already doomed? In billions of years, will it simply fade into nothingness? Or will it be consumed by a cataclysmic event that reshapes the very fabric of space? Recent cosmological theories offer insight into the eventual fate of our galaxy. One of the most significant events predicted for the Milky Way is its inevitable collision with the Andromeda galaxy. Currently, Andromeda is on a slow collision course with the Milky Way, and in about 4.5 billion years, the two galaxies will merge, forming a new galaxy altogether. This collision will be a violent and destructive process, but it will also create new stars and potentially even new planetary systems in the aftermath. The collision will not be an instant event. Instead, it will take millions of years, during which the gravitational forces of both galaxies will wreak havoc on the stars, gas clouds, and interstellar matter within them. But even before this grand merger, the Milky Way will continue to evolve. Over billions of years, most of the galaxy's stars will have burned through their fuel, eventually leading to the galaxy's transformation. As stars die and black holes consume everything around them, the galaxy will lose its vibrant glow, its spiral arms slowly fading as its stars burn out. What happens to the Milky Way in its final stages? Some predict that the galaxy will become a lifeless, dark void, populated only by remnants of dead stars, dying planets, and the ghosts of once thriving star systems. The ultimate fate of the Milky Way could also involve a supermassive black hole. At the center of our galaxy lies Sagittarius A*, a supermassive black hole with a mass millions of times that of the Sun. In the distant future, as stars and gas are pulled toward the black hole, the galaxy might eventually be consumed entirely. This would mark the final death of the Milky Way as we know it, a dark, silent end to the once glorious spiral. While the end of the Milky Way may seem like a terrifying prospect, it's important to remember that this process will take billions of years, far beyond the span of human existence. Still, it presents an existential reflection on the fleeting nature of galaxies, stars, and even the universe itself. What if our galaxy, so familiar to us, is already on a countdown to its end? How will future generations or even species beyond humanity witness this cosmic transformation? Will they be here to see the Milky Way's final moments? Or will they have long since evolved and left for the stars? The fate of the Milky Way challenges us to reflect on the temporality of existence. As we venture deeper into space, we must ask ourselves, how do we, as a species, fit into the grand timeline of the universe? Are we destined to fade into cosmic history, or can we rise above the inevitable death of our galaxy and continue to evolve? This contemplation of the galaxy's demise naturally leads into a discussion about humanity's potential role in the far-flung future, where we may or may not witness the end of the Milky Way. In the next section, we will explore humanity's place in this future, considering the possibilities for our survival or evolution as the galaxy transforms around us. As we contemplate the eventual demise of the Milky Way, we are left with the question, what role will humanity play in this grand cosmic transformation? Will we stand witness to the end of our galaxy, or will we find a way to transcend its fate and continue our journey across the stars? The possibility of humanity surviving the death of the Milky Way hinges on our ability to adapt and evolve. If we are to remain a multi-planetary species, let alone a multi-galactic one, we must develop technologies and strategies that allow us to survive the inevitable changes the galaxy will undergo. Will we continue to exist within the Milky Way for billions of years? Or will we venture beyond its borders to other galaxies and star systems? One possibility is that humanity could one day colonize other galaxies. As our understanding of space travel evolves, the idea of intergalactic exploration and colonization may not be as far-fetched as it seems. New propulsion technologies, such as those utilizing nuclear fusion or antimatter, could allow humanity to travel to galaxies far beyond the Milky Way. But even if we remain within our home galaxy, the technological advances needed to thrive will be immense. Artificial habitats could be developed to house millions of people, shielding them from the harsh environments of deep space. We may create colonies on exoplanets, moons, or even floating cities in the void, where humanity could continue to flourish long after the Milky Way has ceased to be the thriving galaxy it once was. The evolution of human biology and technology will also play a critical role in this future. Could we evolve into a species capable of surviving the extreme conditions of deep space? Or would we rely on artificial enhancements, biotechnology, and AI to maintain our existence? Humanity could one day transcend its biological roots, merging with machines, or developing forms of life that can endure in the farthest reaches of space. However, the question of whether humanity will survive the death of the Milky Way is not just about technology. It is also about our collective will to survive and adapt. Will we choose to expand, to reach beyond our galaxy, and to continue our search for knowledge and understanding? Or will we fall into the traps of division, conflict, and stagnation, doomed to become a forgotten species in the cosmic timeline? What if humanity becomes more than just a part of the Milky Way? Could we one day reach beyond it, leaving our mark on the cosmos? The potential for humanity to evolve beyond our galaxy is not just a distant dream, it is an attainable goal. With the right advancements in technology and the will to explore, humanity could not only survive the end of the Milky Way, but thrive in a galaxy-spanning civilization, living on long after the final stars in our galaxy have dimmed. In the final section of this chapter, we will consider humanity's legacy and the eternal quest for knowledge that has driven our species to the stars. What will we leave behind, and how will we be remembered in the cosmic timeline? As we look to the distant future and consider the challenges and triumphs of space exploration, one question remains at the forefront. What will humanity's legacy be? How will we be remembered in the grand story of the universe? Will we be remembered as a species that conquered the stars, leaving a trail of knowledge and enlightenment? Or will we fade into the annals of history as yet another fleeting civilization lost to time? The drive to explore and understand the cosmos has been part of humanity's identity for centuries. From the first philosophers who pondered the heavens, to the scientists who built the first telescopes, humanity has always sought answers to the questions that arise from gazing at the stars. This relentless pursuit of knowledge, this eternal curiosity, has defined us as a species, and it will continue to shape our future. Even as the Milky Way fades and the universe moves toward its eventual end, the legacy of humanity may persist. If we succeed in our efforts to become a multi-planetary species, our exploration of space could lead to the preservation of human knowledge and culture across the stars. Perhaps our artifacts, our achievements, and our wisdom will be discovered by future civilizations, whether they are human or alien, who will uncover the trail we left behind. Our legacy could be immortalized, not just in history books, but in the very fabric of the galaxy itself. Could the legacy of humanity be immortalized in the stars themselves? The galaxy holds the key to our eternal quest. The knowledge we uncover, the civilizations we establish, and the discoveries we make could echo through time, leaving an indelible mark on the universe. In a future where humanity has spread across the stars, our story could be told for eons, a testament to the spirit of exploration and discovery that has driven us since the dawn of civilization. The eternal quest for knowledge is not just about finding answers, it's about the questions we ask along the way. As we venture further into space, we will continue to question, to seek, and to learn. The legacy of humanity will be shaped by this pursuit of understanding as we become part of the larger story of the universe. Whether we are remembered as the species that first ventured into the stars, or as one of many civilizations that have risen and fallen across the galaxy, our quest for knowledge will remain our most lasting achievement. As we conclude this exploration of the Milky Way and humanity's place within it, we are reminded of the infinite potential that lies ahead. The universe is vast, and its secrets are waiting to be uncovered. Humanity's legacy in the Milky Way is not yet written, but it will be shaped by the choices we make, the discoveries we pursue, and the questions we continue to ask. The journey of knowledge is never truly over. It is a quest that will continue to inspire and drive us for as long as we are willing to explore. As we stand on the precipice of the unknown, gazing into the infinite expanse of the Milky Way, one thing is certain: the journey is far from over. What lies hidden in the galaxy? What mysteries remain just out of reach? The Milky Way, vast and mysterious, continues to reveal its secrets to those brave enough to explore its depths. But this journey, this quest for knowledge, is not just for the explorers of tomorrow, it is for all of us. The Milky Way holds countless stories yet to be discovered. We've only scratched the surface of its secrets. From the dark matter that binds the galaxy together to the possibility of life on distant planets, there is so much more to learn. And as humanity ventures further into space, we will continue to unlock the mysteries of our galaxy, one discovery at a time. The future of the Milky Way is uncertain, but it is also filled with possibility. The galaxy will continue to evolve, just as we do. And as we embark on this journey of discovery, we must remember that the quest for knowledge is never truly finished. Each answer leads to new questions, and with each new discovery, the horizon of understanding stretches ever further. The galaxy still holds countless mysteries: what lies beyond the black holes, the strange signals from deep space, the hidden worlds waiting to be discovered. The answers are out there, waiting for those willing to look. The journey of discovery is endless, and the Milky Way will continue to be our guide. As we close this chapter, we invite you, the viewer, to join us on this ongoing journey. The Milky Way is vast, but it is not infinite. The galaxy holds secrets, and it is up to humanity to uncover them. Will you continue the journey of discovery? Will you continue to ask the questions that will lead us into the stars? The journey doesn't end here. The galaxy still has secrets to reveal. Will you be there to explore them? The Milky Way is waiting. And so is the future.